Since 2006, Carbfix has grown from a small project into a permanent solution to capture and permanently dispose of CO2. This can be achieved either from emissions or directly through the air. During the first years of the project, the main focus was to optimize the process through lab experiments, studies of natural analogs, and the characterization of the pilot injection site. Also occurring at the same time were the design and construction of gas capture, as well as the injection and monitoring of equipment. After preparation, the next step was the pilot phase. Pilot injections were carried out in 2012 at the Carbfix pilot injection site, located a few kilometers southwest of Hellisheiði power plant in Iceland. Results of the pilot injection were published in Science in 2016 and was able to confirm the rapid mineralization of the injected CO2. The result? 95% of the CO2 injected into the Carbfix site in Iceland was mineralized to stone in less than 2 years. Prior to these findings, the belief was this process would take thousands of years. The process begins by capturing the steam after it's spun the turbines. The captured steam gets fed into a tower at the bottom, while at the same time cold water gets fed into the tower at the top. The result is water filled with dissolved carbon dioxide. Next, all that soda water gets pumped up to a mile underground, where, quote, it reacts with the rock underneath us to produce new types of stones, end quote, Peter Mar Gislason explained. This is why Reykjavik Energy calls this project Carbfix, because the carbon is getting fixed into rock. The Carbfix method is a great way for fossil fuel-based power plants to reduce their carbon emissions and capture existing pollutants. Here are all the reasons why this could be huge. First off, it prevents massive potential for climate change mitigation. Reducing CO2 levels in the atmosphere is one of the main challenges of this century, and Carbfix mitigates climate change by injecting CO2 at select geological sites. Next up, we have storage security. The Carbfix method adds to the storage security by dissolving the CO2 prior to or during injection, and by the rapid and permanent mineralization of the injected CO2. Finally, it has a wide geographic feasibility of application. The geology required for Carbfix is the most widespread igneous rock, basalt. It is found worldwide and is abundantly present in the U.S. along the West Coast. It enables the possibility of doing carbon capture and storage, or CCS, in areas where it had not previously been considered feasible. Like any great innovation, it is not without risk. The main drawbacks are, first, not 100% of the carbon dioxide is stored. The risk of leakage is generally considered to be very low, around 5%. Much of this risk is eliminated once the injected CO2 is dissolved into the aqueous phase, as CO2 saturated water is denser than CO2 free water and will sink rather than rising back to the surface. Second, meanwhile, injections cost around $130 per ton of CO2. Due to a lack of a price on carbon emissions, power companies have little incentive to invest. 25 tons of water are required for every ton of CO2 converted. However, seawater could also be used in the reaction, potentially reducing the costs. Carbfix is increasing its presence at various European sites and has the potential to be used in a universal setting. Beginning in Iceland with ideal geothermal conditions, the carbon capture and storage process is being implemented across Germany, Italy, and Turkey as part of the Geothermal Emission Control Research Project. In taking this jump to universal application, the Carbfix project, originally capturing pure CO2, is rebranding itself as Carbfix 2, integrating a dual capture of carbon with elements of hydrogen. This process not only neutralizes acidic waters, but reduces the cost of the CCS system from $130 per ton to under $25 per ton. Carbfix 2 is aiming to inject the solution into seawater, rather than basaltic rock, to generalize the process and increase its accessibility. A Carbfix scientist notes that it's not the solution, but it's one of the solutions that can be used in the fight against climate change, and we will need all the solutions possible for this huge problem to be solved, end quote. A step in the right direction and another crucial tool in the toolkit to solve this major problem confronting our generation, not decades down the road, but this very moment.